Okay, so when we're talking about day length, it is one of the contributors to what causes the seasons, although it's not what's causing heat or light intensity. Remember, daylight, daytime and nighttime is simply the sun, hitting one face of the earth or one side of that sphere that's our earth. So what I did first was write out everything that I wanted to show in the diagram, and then I diagrammed it. Okay, so what I have here are certain things that you needed to know, and then the root cause of why day length changes. Okay, so first off, we know that day and night is caused by rotation. So that was like 4 or 5 weeks ago. We kind of started with that. Okay, our Earth rotates on its axis. So you have to know that in order to understand day length. Day is caused by the side of the side of the Earth that's facing the sun, and it rotates on its axis. Second thing you need to know is that the Earth is tilted on its axis towards the North Star 23.5 degrees. Yeah? Good. Okay. Then you also need to know that the Earth revolves around the sun, and that tilt is still in play, and that our rotation is still in play. So when we model that, we've got this rotating, and then we've got it revolving, and it is always, no matter where it is in our revolution, tilted towards the North Star. Eyes here. Always tilted towards the North Star. All right, so with those three things, then we need to recognize that the position of the Earth's tilt in relation to the sun changes as it revolves. So the position of the North Pole to the North Star never changes. And it's important to note that we aren't tilted because the North Star is over there. We are tilted and we happen to notice, hey, that star in the sky never moves. That star in the sky has always been there. It's a good way to reference. It's a frame of reference for how our Earth is tilted. Okay, so we noticed in the night sky centuries ago that star was always in place in the same spot in the sky, and so we navigated off of it. So it was important for us to recognize, like, okay, it's over there, and we're kind of tilted in this direction, but the important thing about day length and seasons, when we come down to it, is that the tilt of the Earth's relation to the sun. So watch as I model this, okay? In this position, the tilt of the Earth related to the sun, the North Pole is tilted away from the sun. In this position, the North Pole, its relation to the sun is that it is tilted towards the sun. And in these positions, it's neutral. It's not tilted towards or away from the sun in these positions. So, because that axis never wobbles, and because we revolve around the sun, that is the thing that changes the tilt in relation to the sun. Okay? So we can be in this position, still pointed towards the North Star, and be tilted towards the sun. And we can also be in this position, pointed away from the sun, but still pointed towards the North Star. Then, there's one more factor at play, where you are located latitudinally. Okay? So, latitude location in relation to the poles. So how close you are to either pole has an effect on daylight hours, has an effect on the seasons. Okay? Also, according to our position in its orbit, because of the tilt, because we rotate. All those things together go into play with what causes day length. Right, so knowing all of that and bringing it all together, and these are the root causes for the seasons as well. So, to diagram this, after I listed all this stuff out, do you want to move that in this direction so we can kind of see? So what I did was I said, okay, I want to show number one in my diagram. Day and night is caused by rotation. Okay, so I drew the sun because I did know, like, the face of the Earth that is facing the sun, that's going to be in daytime, and that's going to be at night, okay? So I needed to draw the sun, I needed to draw the Earth, And then I needed to draw the rotation. So I'm concerned they're not able to see that. Move the camera here. I am going to post the picture to people who need to see this. Maybe I'll put it on Google Classroom. Thank you. All right, so here's the Earth, and this is the equator, and I'm showing the rotation. It's going counterclockwise. Okay, so it's spinning. Then number 2, Earth is tilted on its axis towards the North Star 23.5 degrees. So although I didn't draw the North Star, which is like miles that way, I still have the axis, and it is tilted in this direction, in this position. Then number 3, Earth revolves around the sun. So because the focus isn't on revolution, it's not about years. Eyes up here, please. Okay, I just briefly sketched. It goes this way, a different position in our orbit, and then it comes back to this position. Okay, so the position of the Earth's tilt, or the Earth revolves around the sun, that's that. And then the position of the Earth's tilt in relation to the sun. So I have the sun, I can see the Earth's tilt is towards the sun in this position, but then also it changes as it revolves. So when it's in this position in its orbit, it's still tilted in the same direction, but in relation to the sun, the North Pole is away from the sun. And then finally, I drew my lines of latitude. Okay, so that's what these lines are. That's the equator. These are different lines of latitude. And I pointed out that day length is different according to our position in orbit and if we are tilted towards or away from the sun. So here's my daylight hours. This means more. So I have more at the North Pole, and it decreases. It gets less daylight hours as we go towards the South Pole in this position. Now, if we were to do this position and I were to draw this in detail again, that would be reverse. You'd see daylight hours going from more to less from the South Pole to the North. Now let me demonstrate with a physical model. Shift it over here. Okay. So I'll use this one. I've got this globe, okay? And in this position, we have the summer solstice. This is our seasonal position, okay? And so lines of latitude are important. Where you are in relation to the poles. If you're up here on this day in this position, you have 24 hours of daylight. Yeah? And as you go down in latitude towards the South Pole, that decreases to 0. And do you remember my big aha from yesterday?
Mm-hmm. Yeah. No matter what.
This is what led to it. This realization, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Check this out. 24 down here, hours of daylight. 23, 22, 21, 20, 19, 18, 17, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 hours of daylight at the North Pole in this position, winter solstice. And then as you revolve around, those times shorten or lengthen for each line of latitude. And so here in this position, everybody's got 12 hours of daylight up here and down here, and the equator. And it's always 12 hours at the equator because it's in the middle of a ball. It's in the middle of the sphere. So, yes, ma'am.
Is that why you put Ben asking me what I like?
Because I discovered it in here. I hadn't told my other classes about it, so I just wanted to share. And the reason why I did that is I'm 41 years old. I've been teaching this unit for 3 years out of my 7 years in this position. And yesterday in your class was a new connection for me, a new realization. And I don't say that to embarrass myself. I don't say that to be like, oh, Mrs. Rudd doesn't know her stuff. No, like, it just was a connection. It was a realization. Like, you can learn new stuff no matter how old you are, no matter how much you think you know. That quote came true for me yesterday that you wrote on the board. Did anybody read my quote?
I look at it, but I can't picture it right now.
Right? Can you read it to us?
It's what you learn after you know everything that counts.
Yeah, so thinking I know everything is funny. I'd never say that. I don't know everything, okay? But thinking I know my subject really well, yes, I have it down. Like, I understand the concepts. I get it. I can teach it to you. No problem. but that was a big aha moment for me yesterday. And it's just fun and exciting to share new learning with people. So there you go. Yeah? Okay, so we have that, and we have the diagram, and we have the physical model. So you notice that I am asking you to pick all this stuff up and make connections. And now one more skill to help you learn this stuff, you need to copy those 5 things down in that diagram on the back side of page 14. Clear? Thank you very much. I'm going to stop this now.